Hey everybody, this is your AP Stats in Memoriam section where I'm going to go over some of the 2018 free response questions. From what I heard from a lot of you is that it was a rather difficult test, and I'll go ahead and say I probably agree that this was a difficult test. It was more difficult than what I think the last year, but definitely there was a lot of people who probably could have done pretty well, I think. We went over everything. We didn't necessarily spend a lot of time reviewing all of these, but um, it wasn't impossible, but it was moderately difficult. Anyways, pause to remind yourself, pause, read over the problem again, and I'll get to the answers. By the way, I'll also add the rubric and the answers are not actually published yet. So this is just me doing the problems to the best of my ability. And as you've learned, I have made mistakes before. So we'll see. Anyways, identify and interpret in context the estimate of the intercept of the least squares regression line right here. Hopefully you didn't accidentally say slope. It says identify and interpret, so 7295. If you want to interpret that, that means when there's 0 customers in line, we're expecting to wait about 73 seconds. Identify and interpret the context of the coefficient of determination r squared. It says it right here. And that's when we would say about 73% of the variation in time can be attributed to the variation in customers in line. Everything else would just be in the residuals or another factor. One of the data points was determined to be an outlier. Circle a point on the scatter plot. Explain why the point is considered an outlier. There you go. You should say something along the lines of, it just doesn't fit the general pattern with the other points. No further explanation is really needed. Oh boy, this problem. So go ahead, read it again. It talks about the AP environmental science teacher, or I guess I imagined it was AP. I guess I just imagined this person was Stockwell. So based on the 95% confidence interval for the proportion of all students at the school who would respond yes to, do you regularly recycle plastic bottles? It's between 58.4% and 81.6%, which is generally a pretty wide window. So you would think that that sample size is probably decently small. People said they kind of struggled with this, but if you think about any interval, p hat's in the center. So you have I think they refer to it as a point estimate. It's a p hat. So on the low end, 584, and on the high end, 81.6%. That means dead in the center is our p hat. Or I added 81.816 and 0.584, added them together, divide by 2 to find what's in the middle. The midpoint right there, p hat, is 0.7. So okay, so I'm going to show a little math. So we're thinking from here to here and here to here is going to be the same, which is just our margins of error, or margin of error here. I think actually subtract them, find the distance, would have been 11.6%. So when you remember margin of error is equal to your critical value, Z star, P hat, Q hat over N. A margin of error is 11.6. 95% is 1.96, square root 70, 30 over N. Solve it. Those are problems that we have similarly done before. So divide both by 1.96. Then you're going to square both sides. I'm going to move all of this over here. So we had, once I did the division and I squared it, I would have had 0.70 times 0.30 equal to 0035 over N. And like I said, that came from the 0.116 divided by 1.96. Then I squared it. Cross multiply, that's just going to be 0.21. So 0.21 is equal to 0.0035 over n. Divide by that decimal. And you should get, I think I got 59.95. I'd probably say just round it up to right about 60. B, given the method used by the environmental science teacher to collect the responses, explain how bias might have been introduced and describe how bias might affect the point estimate. So when it says the teacher selected a random sample of students, each selected student went into the teacher's office one at a time and was asked to respond yes or no. So I think part of the bias comes in, you would assume that an environmental science teacher is passionate about the environment and that they would be, somebody would be more inclined to tell the environmental science teacher that they do recycle when in fact they may or may not. Also, if that teacher is your teacher and going to be giving you a grade, you might just say anything that they want to hear. So if you write out either anything along those explanations and indicate that you're like the 70% that was found is probably an overestimate because you're just saying something that this environmental science teacher wants to hear, I think you'd probably get full credit on that, which would be a form of response bias, but I'm not sure that that's actually going to be in the rubric or not. But I'm not going to get all of C on this video, so I'm going to end it here. Especially because, well, this one's a doozy.